Hello, this is question number 43 from section 6.4 of Walker Physics 4th edition. We've got an Atwood machine here. So an Atwood machine is simply two weights pulled over a pulley. So when you think of the force that's pulling on the tension on that string, it's equal to gravity times the mass. And if the masses are exactly the same, then it'll be in equilibrium because it will be just like a tug of war and two equally sized forces are pulling on that string. But if you've got one that's bigger and one that's smaller, then you'll have an acceleration. Now, the acceleration can be very, very small. So if you could make, say, one weight 99% of the other weight, okay, so that the gravity is pulling on that string in the other direction and it is pulling on the other side, you can make that Atwood machine go accelerate, but accelerate very, very, very slowly. It wouldn't be like dropping something. If you drop something and you know what the acceleration of gravity is, 9.81, it would just furiously fall and you wouldn't even be able to see it. But if you finagle your Atwood machine just right, you can make it accelerate really slowly so that you would be able to see it and study it a little clearer. So this picture's got definitely a bigger mass. M2 is bigger than M1, so we're going to think that it should accelerate to the right. So the littler mass would be brought up and the bigger mass would come down. All right, so let's look at the ugly math in this, because what's going to happen it's no big deal as long as they're the same, but if you add weight to both, then what's happening? Because you've got two directions. So let's look at it first. First of all, what's causing the acceleration? It's Newton's law. So you've got force equals some kind of a mass times an acceleration. Now, as this is coming down, there's two masses here. There's this mass and this mass. So this M that we're talking about is actually both masses added together. So we're going to have it here as F equals M2 plus M1. Let's do it the other way. M1 plus M2. Okay. Multiplied times A. All right, so there's your next step. Now what is the force? What is the net force? Okay. The net force is going to be mg in this direction minus mg in this direction. See, it's because mg, the small guy, is pulling this way, which is opposite of here. So this one is going to accelerate down. This one is actually pulling up. So you have to subtract the small mass times gravity. So this F equals M2 times G minus M1 times G. Okay, that's what this is. That's what that F is. So I'm going to rewrite it all, and I'm going to have M2G minus M1G equals M1 plus M2A. Oh, that's awful. Okay, well, algebra, I've got a G here common, so this is G times M2 minus M1 equals M1 plus M2 times A, right? So let's solve for A, because they're going to ask, does the acceleration increase? So let's find out what the acceleration is first. This is before I add anything. So I'm going to have G M2 minus M1 over M1 plus M2 equals A. That looks awful. Okay. Now, the question says, does the if you add 1 kilogram to both sides, okay, a kilogram to both sides, what happens to the acceleration? All right, so I already know that A equals G times M2 minus M1 over M1 plus M2, okay? So let's add a 1 to both. So let's see, G times m2 plus 1 minus m1 plus 1, okay, over m1 plus 1 plus m2 plus 1. So what are we going to do? Okay, this becomes a minus m, this becomes a minus, so let's do it this way. This becomes a minus m1, this becomes a minus 1. So this is m2 plus 1. All right, you see my 1's will cancel. And this is going to be g times m2 minus m1 over, all this is equal to a. What's this going to hit? This is plus plus plus, so this is going to be m1 plus m2 plus 2. All right, so let's look at these two. Here's 1, and what was the other one here? All right, what happens to the acceleration? These are exactly the same on the top, same on the bottom, but the bottom is a little bit bigger. This bottom is a little bit bigger than this bottom. So if this bottom is a little bit bigger, it's being divided into this number. What happens to A? A would have to reduce. Okay? So whatever the acceleration is here, you're going to have a slower acceleration. Now, I don't know what the acceleration is. This is breaks my brains, but it will be slower, and I think that's all they're asking for. Okay, so does the acceleration of the blocks increase, decrease, or stay the same? It would decrease. Okay, so that's A. It would decrease. Choose the best explanation. Okay, so what do we see? The net force acting on the blocks is the same, but the total mass must be accelerated is greater. Oh, that looks good right there. This mass is bigger that's being accelerated. Okay, the total mass accelerated is bigger, which means okay, I like number 1 a lot. Let's look at number 2. The difference of the masses are the same. Difference of the masses are the same. And this is what determines the net force. No, it doesn't. The force exerted on each block is greater, leading to an... Nah, stupid. That's the only one that makes sense. Okay. I hope this helps your education.